So today I'm going to be talking about impact, specifically central impact. Central impact occurs when the direction of motion of the mass centers of the two colliding particles is along a line passing through the mass centers of those two particles. Halfway through the collision, there will be what's called a maximum deformation, where both of the two particles will move with a common velocity, they'll move at the same rate, and their relative motion to each other will be zero. So they're kind of like stuck together, moving together at the same rate. After the collision, or after, I'm sorry, the maximum deformation happens, they'll start to separate and you'll have a period of restitution. And one of two things can happen during the period of restitution. Either it will return, the two particles will either return to their original shape or they'll remain permanently deformed. If they return to their original shape, that's when the coefficient of restitution is equal to 1. That's considered elastic impact. And the other option is plastic impact, when coefficient of restitution equals 0. And that's when they just get stuck at the maximum deformation, where they get deformed, and then they stay together, and then they move as basically one object. And that's plastic deformation, which doesn't happen very often. What you'll have is a coefficient of restitution between 0 and 1, not hardly ever actually 0 and 1. So let's kind of work through a problem really quick, and I'll kind of talk more about how the coefficient of restitution affects the problem as we're going. You can see I've already written down the given and the find and two equations that we'll need in order to solve the problem. I'm working on problem 15.59 out of Hebler's Engineering Mechanics Dynamics book. And I'll go ahead and actually just read the problem so you guys can kind of understand what I've written down here. The 5 milligram truck and 2 milligram car are traveling with the free rolling velocities shown just before they collide. And in the pictures it shows the truck going 30 kilometers an hour and the car going 10. After the collision, the cars move with a velocity of 15 kilometers per hour to the right relative to the truck. So that's what the VCT is. Determine the coefficient of restitution between the truck and car and the loss of energy due to the collision. Now I'm not going to be solving for the loss of energy because that takes a bit more time than we have. So I'm just going to be solving for the coefficient of restitution between the truck and the car. So let's go ahead and jump right into it. What we need to find is the coefficient of restitution. So we'll need VB2, VA2, velocity of A and the velocity of B. So that's the VB2 is the velocity of the truck, the final velocity of the truck subtracted by the final velocity of the car over the velocity of the car minus the velocity of the truck. Now we already have VA and VB. What we need to solve for before we can solve for E is we need to find what the final velocities of the truck and car will be. So in order to do that, we'll need to use the conservation of momentum equation. Right there. We need to use that to solve for the final velocities. In order to make this simpler, I'm going to convert the velocity of the truck and the car from kilometers per hour into meters per second. So we have Vt equals 30 times 1000 over 3600 for the time. And that's going to equal 8 point 3.33 meters per second. Now do the same thing with the velocity of the car, and that ends up equaling 2.78 meters per second. Not meters per 8, meters per second. Okay. So now we can go ahead, now that we have the velocities in meters per second, we can go ahead and use our first equation down there and kind of do a plug and play, and we'll see what we have. So we have our mass of the truck, MA, which is 5,000, times the velocity of the truck, is 8.33, plus the velocity of the car, the weight of the car, which is 2,000, the mass, times the velocity of the car, 2.78, equals mass of the truck again, times, now this is what we don't know. We don't know the velocity of the truck, the second, or the final. We also don't know the final velocity of the car. So that's two things we don't know in one equation, which means we need to use a second equation to solve for the velocity in the car. So we're going to use the equation final velocity of the car equals final velocity of the truck plus, this is the VCT, which we know to be from our given 15 kilometers per second. So we need to convert that as well to meters per second, which ends up equaling 4.167 meters per second. Now we can plug that in. So now we have some important equations. We have this one here, kind of highlight that a little bit, and then we have this one here. These are the two equations that we're going to need for solving for the final velocity for the truck and for the car. We have two equations, two unknowns. I'm not going to write all of it out because I don't think I can actually fit it across this page. But using the solve function on the calculator, not too hard, we get the final velocity for the truck equal to 5.56 meters per second, and the final velocity for the car equal to 9.72 meters per second. Now that we have the final velocities for the truck, the car, and the original velocities for the truck and the car, we can solve for the coefficient of restitution, which, if we look over here, I already have it written down. And I think I told you the wrong thing for all of these. VB should be the velocity, the final velocity for the car. VA is final velocity for the truck, and then the velocity for the truck, VB, velocity for the car. I think I told you the opposite earlier. So we have 9.72 minus velocity, final velocity for the truck, which was 5.56 0.56. That is over the velocity of the original velocity of the truck. I'm sorry. Yeah, that's right. The original velocity of the truck, 8.33, minus the original velocity of the car, which was 2.78. Which brings us to a coefficient of restitution between the truck and the car of 0.75. There are no units for the coefficient of restitution.